Hi, Chem 101 students. Welcome back for the second lecture this week. This is about stoichiometry. So what stoichiometry is using the molar masses, which we learned about in the last lecture, and a balanced chemical equation, which we learned about last week, to find the quantities in a chemical reaction. So this is a super useful thing that's used all the time in all kinds of fields. In pharmaceutical chemistry, you want to know how much of a drug product you can get from certain reactants that you're using to make it. This may be really important for economic reasons. In addition, if you're running a big factory that is making plastic or any of the other things that we use all the time, you want to know how much stuff you can make given the starting materials that you have. And all of this is related to stoichiometry. So in last week, we talked about how to balance chemical equations, and we had an equation like this, and we would translate it in this way, where we have 4 lithium atoms reacting with 1 oxygen molecule, and we get 2 formula units of lithium oxide. So now we know that we call these formula units from the last lecture because lithium oxide is ionic. So we wouldn't call this a molecule. Instead, it's a formula unit of an ionic compound, and we have 2 of those. So again, the way we knew to balance these is that we have the same atoms on each side; they're just bonded differently. Now, the way we can translate it, and the way we translated it last week, is it meant that 4 lithium atoms react with 1 oxygen molecule to produce 2 formula units of lithium oxide. But realistically, that's not very useful to us because we're not usually going to be working with individual tiny little atoms. It's just not really possible. Instead, we'll be working with many, many atoms, moles and moles of atoms. So we want to scale this recipe up so that it represents a realistic amount of reactants and products. So to scale up this recipe, we could scale it up by a mole. And instead of saying 4 lithium atoms, we could say 4 moles of lithium atoms. Reacts with, instead of 1 molecule, O2 molecule, 1 mole of O2 molecules. And then this produces finally 2 moles of lithium oxide. So the coefficients tell us the number of each atom or compound that reacts, and we for most cases will want to state this in moles. We can use either. Either will work, and we should use whichever interpretation is useful for answering our question. But usually it will be the mole amounts that are useful because that's a more realistic amount of stuff. Okay, so I called this scaling up a recipe, and stoichiometry really does work a lot like a recipe in cooking. If you have a recipe that's going to make pancakes, it will tell you that your reactants here are like 1 cup of flour, 2 eggs, and a half teaspoon of baking powder, and your product here will be 5 pancakes. So a chemical reaction is really just a recipe for chemicals. What it works exactly the same way as a recipe for making cooking. Cooking is basically a type of chemistry. You're reacting these together and producing something different from them, something that you would actually want to eat. So this can give us a relationship. This tells us if we have 2 eggs, assuming we have enough of everything else, we can make 5 pancakes. Or if we have just 1 cup of flour, assuming we have enough eggs and baking powder, we can make 5 pancakes. And we can also scale this up and figure out how much pancakes we can make from 2 cups of flour, for example, or so many eggs. So the relationship, if we're focusing on just eggs, we could focus on any of these, but let's say we're focusing on eggs. If we have 2 eggs and enough of everything else, that will give us 5 pancakes. So that's a relationship that we can use to figure out how many pancakes we can get from a certain number of eggs. And it shows a numerical relationship between the pancake ingredients. So if we have 2 eggs and enough of everything else, we can make 5 pancakes. And this is the relationship. 2 eggs equals 5 pancakes, or 2 eggs per 5 pancakes. That is a conversion factor that we can use to convert between how many eggs and how many pancakes. So let's say we have 8 eggs. We want to know how many pancakes. Well, we'll use that ratio. We start with our 8 eggs. And then the ratio we had was that 2 eggs makes 5 pancakes. So we're going to put the eggs on the bottom because we want our A unit to cancel. The 2 goes with the eggs cancel, and we had that 2 eggs makes 5 pancakes. So to figure out how many pancakes we can make, we do 8 times 5 since it's on top, and divide by 2, and that gives us 20 pancakes. So 8 eggs can make 20 pancakes. And just like we did for this recipe here, we can do the same thing in chemistry. We can figure out, depending on how much stuff we start with, how much product we can make. Or likewise, if we wanted to make 20 pancakes, we could go back and figure out how many eggs that would take as well. And so now we're going to do the same thing, but we're going to do it with chemicals. The big difference is that we aren't usually given how many atoms or molecules that we're starting with. Instead, we weigh out how much we start with. So the first step of any of these calculations is going to be to convert the grams of, let's say, oxygen molecules like we have here into how many oxygen molecules that is. So we have here how many grams of lithium would be needed to react with 43.2 grams of oxygen. So the first thing to do is we have to figure out how many moles of oxygen that is. And so we got to convert grams to moles. Do you remember how we convert between grams and moles? We got to use the molar mass, right? And so if we have 1 mole of O2 here, that gives us 2 moles of oxygen atoms within it, because every one of these has 2 oxygen atoms. And so if we want to know how many grams that is, well, we go to the periodic table and we see that it's 16 grams of oxygen per 1 mole of oxygen. So 16.00 grams of oxygen is 1 mole of oxygen atoms, and we've got 2 moles of those. So our moles of oxygen atoms are canceled. We'll get how many grams, and so 1 mole of O2 is going to be equal to 2 times 16, or 32.00 grams of O2. Okay. So 1 mole of O2 is 32 grams of O2. And so we'll need to use that to convert between moles of O2 and grams of O2. So let's start. Let's do this. We're going to use the molar mass to convert the mass to how many moles. We have 45.3 grams of oxygen, and we want grams of oxygen on the bottom, so they cancel. And we figured out on the last slide that it was 32 grams of oxygen was 1 mole. So we're going to put 32 next to the grams of oxygen, and that is equal to 1 mole of oxygen. Our grams of oxygen cancel, 1 mole of oxygen. So now we divide. So let's break out our calculator again. 45.3 divide by 32. And we get the 3 sig figs, 1.42, and our units are moles of oxygen. 1.42 moles of oxygen. So now we have how many moles of oxygen molecules. So now we can relate that to how many lithium atoms are going to react with that. Yeah, the mole part is on the top, so that the grams will cancel. So that's what step 2 in stoichiometry is going to be about. So now that we know how many O2s, we can relate that to how many lithiums. The relationship is going to be in the recipe, also known as the balanced chemical equation, which is the recipe for chemistry reactions. Note that the question asks for lithium. So if we look at the equation, it does tell us also how much lithium oxide could be produced. But the question didn't ask about lithium oxide, so we don't need to concern ourselves with that. What we need to do is look at the lithium. What this tells us is that 1 mole of O2s will react with 4 moles of lithium. And that's what I need to know. And from the previous slide, we had determined we had 1.42 moles of oxygen. And what we're using here is 1 mole O2 will be equal to, in terms of reactions anyway, 4 moles of lithium atoms. Okay? Now it's going to be the moles of O2 that we want on the bottom because they have to cancel. So we're going to put our conversion factor, and we're going to make sure the moles of O2 go down here. they cancel. So this is going to be the part that goes on the bottom. 1, because of the coefficient right here, 1 mole of O2. And so our moles of O2 are going to cancel here, and on the other side we're going to put the 4 moles of lithium. 4 moles of lithium. Okay, and that's going to get us how many moles of lithium atoms? We just have to go back to our calculator now. And so we do 1.42, and then times 4. We could divide by 1, but it doesn't make a difference. We get 5.68 moles of lithium. 5.68 moles of lithium. So now we know how many moles of lithium, but in the question, they asked us how many grams of lithium would be produced. So we're going to have one more step. We've got to convert these moles of lithium to a number of grams. Okay. So step 3 is to go from moles back to grams. The moles of because we were asked how many grams of lithium would be needed to react. So we have to change the moles to grams. How do we change between moles and grams? Hopefully that will be on the tip of your tongue every time. It's the molar mass. We need the molar mass of lithium. And so we can go look for that on the periodic table. We find it right here. It's just atoms, so we can read it straight off. 1 mole of lithium atoms is 6.94 grams of lithium atoms. So that's what we're going to be using. Okay. So finally, we're going to write from the last slide. Before we had 5.68 moles of lithium. You know what's going to go down here? Better be the same as right here, right? Mole of lithium. And what we determined was that 1 mole of lithium was 6.94 grams. We got that from the periodic table. So we put 6.94 grams of lithium up here. And now we're going to have grams of lithium. That's what the question asked for. All we've got to do now is multiply 5.68 times 6.94. And we got to 4 sig figs, or 3 sig figs, 39.4. We're going to have 3 sig figs because these have 3 sig figs. So 39.4 grams of lithium. And that was what the question asked for. So we're done. Remember that the mole part goes on the bottom, the cancel, the gram part goes on top. And we've answered our question. So we did 3 steps here. 3 steps to do this, right? And for stoichiometry, it's always going to be the same 3 steps. So if we did this all together, which we can do it all together, step 1 was going from grams of oxygen to moles of oxygen. And remember, to go between grams and mole, we use the molar mass. So it was 1 mole of O2 was 32 grams of O2. That's what we used. Then we went from moles of O2 to moles of lithium. That was step 2. For step 2, we always use the balanced equation. 4 moles of lithium for 1 mole of oxygen. We get that from the balanced equation. Finally, step 3 was going from moles of lithium to grams. And remember, to go between moles of grams, we use the molar mass. We got this from the periodic table. Now, a very common mistake that people will make is they will use the balanced equation in steps 1 and 3. No, no, no. The balanced equation is only used for step 2. Only step 2, okay? Don't ever use these coefficients for step 1 or step 3. For those, you use the molar mass. What the molar mass means is the mass of 1 mole of that stuff, okay? So don't put a 4 here. The 4 moles of lithium does not weigh 6.94 grams. 1 mole of lithium does. The only time you should be using the balanced equation is in step 2. Only step 2. Okay. So, to do this all in one step, we start with the 45.3 grams of oxygen. We write that down. And we note we're going to go from grams of O2 to moles of O2 to moles of lithium to grams of lithium. We use the molar mass. We put the grams of O2 part on the bottom, right there. The number that goes with it is 32. The grams of O2 cancel. The other side is 1 mole O2, that goes up here. And when we stopped here, we got the moles of oxygen, but we don't got to stop. We can keep on going. Okay? We just know that since moles of O2 is right here, moles of O2 better be down here, okay? And if we use our balance equation, because this is step 2, we say 1 mole of O2, so a 1 goes there, and that reacts with 4 moles of lithium, so that's what goes on top. Our moles of O2 cancel, and 4 moles of lithium on top. Next, we're going from moles of lithium to grams of lithium, and that's what was asked for, grams of lithium. So we know, as usual, whatever unit is here, that same unit better be down here, okay? And in our molar mass, it's always the 1 mole of that substance, so we put a 1 here. Our moles of lithium cancel. And the other side is 6.94 grams of lithium, which we got from the periodic table. That goes there, and that will get us our grams of lithium. And we can punch this into our calculator all in one shot if we like. Remember, just remember this rule. When you're doing these big long ones, if the number is on the top, press times before you put it in. If the number is on the bottom, press divide, and you can ignore the ones. Don't press times before something that's on the bottom, okay? So it's going to be 45.3 divide by 32 times 4, since it's on the top, and then times 6.94, since that's on the top, and we get 39.3 grams of lithium. But on the other side, we got 39.4. What happened? Okay, don't freak out, all right? It's because we rounded on in-between steps when we did it step by step. But remember, there's always a little wiggle room on the last sig fig. So what? We got 39.3 here if we round this up. The last sig fig has a little wiggle room. It's just because sometimes if you round on in-between steps, it will bring the number off just a little bit, but it's still effectively the same thing. It's no different, really, because the last sig fig has a little bit of wiggle room to it. Okay? So 39.4 grams of lithium. So, you know, when you're writing this on your exam coming up later, if you're writing it on the written work and you show it to me one step by step or all like this, either way is fine with me, okay? As long as you show every conversion factor. And in terms of stoichiometry, it's always the same 3 steps. Now, you may not need all of the steps for every problem, okay? But nevertheless, the steps are always the same. The first step is always, if you're given grams, go for the mole. Turn grams to mole. So use the molar mass, and we'll call it substance A, whatever substance we were initially given. Step 2 is the only one where you use the balanced equation. That's used to relate the moles of one substance in a reaction to the moles of another. And so that you'll use the molar ratio, which comes from the balanced equation. This is the only time you use the balanced equation, okay? Only time you use those coefficients, not in step 1 or step 3. Finally, step 3, you go from moles of a substance back to grams. And so you'll use the molar mass of the substance B. Now, sometimes you won't use every single step. Let's say, for example, you're not given grams of substance A to begin with. You're given the moles. Well, then you don't need step 1 because you were given the moles already. Step 1 is all about going from grams to moles. If you already got moles, you don't need step 1. Or let's say they're asking you at the end for the moles of substance B. Well, then you wouldn't need step 3 because step 3 is to get you to grams. But if you're asked for moles, you can stop at the end of step 2. That said, the steps are always the same, okay? Same 3 steps. Whether you need to use all 3 of them or not, they're always the same. So it's going to follow this pattern every time in stoichiometry. So here's another example of a stoichiometry question. How many grams of nickel are needed to make 18.9 grams of nickel 2 chloride? So remember, in steps 1 and 3, you need the molar masses. And here we are given, we're asked for grams, we're given grams. So we're going to need to go between grams and moles for these things. So let's start by calculating the molar masses. Okay. And we do need the balanced equation. Is this equation balanced? Well, it's got 1 nickel, 2 times 1, 2 hydrogens, 1 times 2, 2 hydrogens. and 2 times 1, 2 chlorines, and 1 times 2, 2 chlorines. So it is balanced. We got the balanced equation. We also need the molar masses. Remember, balanced equation is for step 2, and molar masses are for step 1 and 3. So we need to calculate molar mass for nickel 2 chloride. So we got 1 mole of nickel in nickel 2 chloride. And if we go to the periodic table, we see 1 mole of nickel atoms weighs 58.7 grams about. 58.7 grams. And so we have 58.7 grams times 1. That's the mole of the nickel atoms. Now, 1 mole of nickel 2 chloride contains 2 moles of chlorine atoms. We got 2 moles of chlorine atoms. Each weighs 35.45 grams. So 2 times 34.45, 35.45, 70.9. And then we add those together to get our molar mass. So 58.7 plus 70.9. And we get 129.6. So 1 mole of nickel 2 chloride is 129.6 grams of nickel 2 chloride. Now for the nickel atoms, that's pretty easy. We just read it from the periodic table. Molar mass for nickel is 58.69 or 58.7 grams. Either one is okay. All right. So we've got the molar masses. We've got the balanced equation. We're going to need this one for step 1 because we're given grams of nickel 2 chloride. We're going to need this one for step 3 because in the end we're asked to get grams of nickel. So this is like our substance A is nickel 2 chloride and our substance B is nickel atoms. So this one we'll need for step 1, this one for step 3. Okay, so let's plan out our work here. So step 1 is always about going for the mole. So we're going to go from grams of nickel 2 chloride to moles of nickel 2 chloride. For that we need the molar mass of nickel 2 chloride, and we calculated that on the last slide. Then step 2 uses the balanced equation. We want to go from moles of nickel 2 chloride to moles of our substance B, which is nickel. And so we're going to use the balanced equation, which tells us 1 mole of nickel 2 chloride is produced from 1 mole of nickel. Finally, in the end, we're asked to get grams of nickel, so we need to convert moles of nickel to grams of nickel. That uses the molar mass of nickel, and so we have that here. 1 molar mass of nickel, 58.69 grams of nickel. So let's start by writing our data. It's 18.9 grams of nickel 2 chloride. We're going to write that right here. All right, and we're going to use, now we want to go for the mole, right? We're going grams of nickel 2 chloride to moles. And so we're going to use the molar mass to go between grams and moles. And so we're going to use a conversion factor, and we know every time the unit that's down here is the same as the one right here. So we put it right there. And from our conversion factor, it tells us the number that goes with grams of nickel 2 chloride is 129.6. We write that here. And now our grams of nickel 2 chloride will cancel. And then on the other side up here, we write the 1 mole of nickel 2 chloride. That will go right here. We put it right there. Okay, now we've gotten to moles of nickel 2 chloride. We could stop here and calculate it. So let's say we calculated the moles of nickel 2 chloride. We really wanted to do that right now. We could do that. 18.9 divided by 129.6. That would give us 0.146 moles of nickel 2 chloride. So we could do that. We stop there and then apply that to the next step. Or we can keep on going. And it's often, a lot easier to just keep on going. We know we're not done. We got to get grams of nickel first. So let's do step 2. Again, whatever unit is right here, we need it to be right there too, so that they cancel. And we look in our conversion factor that we determined, and it tells us 1 mole of nickel 2 chloride. So we put a 1 there. Will be produced from 1 mole of nickel atoms. Moles of nickel 2 chloride cancel, and we get moles of nickel atoms. So here we would, if we continued, we would multiply 0.146 times 1 divided by 1. We get 0.146 moles of nickel if we stopped here. But we don't got to stop here. We can keep going, and we could finish off step 3. Okay, So here we get, again, we look here, what's the unit here? That better go down here. Okay, right in there, all right? And we're looking at our conversion factor. We have 1 mole of nickel atoms. The moles of nickel atoms cancel, and we write down the other side of our conversion factor, 58.69 grams of nickel. And so now let's calculate this all at once. Here, we actually already did the beginning. We got the 0.146. We can do it again. 18.9, and since this is on the bottom, we'll press divide. 129.6, and this would be then times 1, divide by 1. You don't have to put it in your calculator, but you do have to write the conversion factor, okay? Just because there are both ones here in the second step doesn't mean you can skip writing this conversion factor. You do have to write it, because they're not always 1 here. Then since 58.69 is on the top, we'll press times 58.69, and we get to 3 sig figs, 8.56 grams of nickel. So 8.56 grams of nickel. Okay, and that's your 3 steps of stoichiometry. Always the same, always the same. Grams of the first substance. So this is what we called substance A right here. In general, A, because we were given an initial amount of that. This is our A. You go from grams of A to moles of A. You go from moles of A to moles of B, which was our nickel, then moles of B to grams of B. And that's it. Same old, same old. This is our substance B right here, the nickel, because that's what we were asked about, how many grams of nickel. Same 3 steps every time. Every time. Okay. But sometimes you won't need every step. Okay. It is possible that you may not need all the steps sometimes. For example, so remember what is the purpose of each step. Step 1 is used to convert grams of substance to moles of the same substance. Step 2 is used to relate moles of one product or reactant to moles of a different product or reactant. Finally, step 3 is used to convert moles of your substance to grams of the same substance. So if you're already given moles to begin with, you don't need the first step. Or if you're asked for moles at the end, you don't need the third step. So read the question carefully and decide which steps you would need to use. So this question asks, how many moles of calcium would react with 18.5 grams of O2 in this reaction? 2 calciums plus 1 oxygen makes 2 calcium oxides. And well, we're given grams of O2. So O2 is our substance A here. This is what we would call substance A. And our calcium is substance B. So we have grams of substance A. We need to convert to moles of substance A. So notice the problem begins with grams. We have to use step 1. All right. Okay. We're going to go from grams of substance A, which is O2, to moles of substance A, which is also O2. We'll need the molar mass. Then one ingredient or chemical or substance is related to another. We need to relate our moles of O2 to our moles of calcium. So that's step 2, moles of substance B, which is calcium. But at that point, that's what we were asked for. So we already have moles of substance B, so stop. We stop at step 2 this time because we weren't asked for the grams of calcium. That's what step 3 would be for, but we don't need step 3, so we skip it. We just do step 1 and 2. Stop here. Let's do this problem now. We're not going to get grams of substance B. We don't need it. So first, we need to use the molar mass of the O2. We already figured it out earlier. 1 mole of O2 is 32 grams of O2. So we're going to go for the mole, go from grams of O2 to moles of O2. And if we look back, we were given 18.5 grams of O2. So I'm going to write that here, 18.5 grams of O2. And grams are here, so we better have grams on the bottom. The number that goes with grams is 32. We write that down here. On the other side, that's 1 mole of O2. Our grams of O2 cancel. We put the 1 mole of O2 up top. We calculate. 18.5 divided by 32, and that gives us 0.578 moles of O2. 0.578 moles of O2. Next, we've gone through step 1. Now we need to do step 2. We need to relate moles of O2, how many moles of calcium. And for that, we're going to use the balanced equation. Okay. And so we have from the last step 0.578 moles of O2. So again, we know what unit goes down here. It's the moles of O2, so they can cancel. And we look at how many moles of O2? 1 mole of O2. Okay. And that's going to react with 2 moles of calcium. So we cancel our moles of O2, and on the other side we put our 2 moles of calcium. And now we can multiply 0.578 times 2. And if we round this to 3 sig figs, that gives us 1.16 moles of calcium. And now we stop. We stop, right? Because that's what was asked for. How many moles of calcium? So in this case, we get to stop after step 2. So read the question carefully. It's the same 3 steps every time, but sometimes you don't need every step. Okay, in this case, we did not need step 3. Okay, and that is it for the lesson on stoichiometry. Make sure to practice the homework problems that I give you, and this is a kind of thing where you need lots of practice. So I can lecture to you all day about it, but you're not going to get good at it until you practice. We've already looked at a couple problems. In the next lecture, we're going to look at a few more even. But it's the same 3 steps. You just got to get good at doing those 3 steps, and that's going to take some practice. So if you finish all my homework that I give you, again, there are still example problems in your textbook with answers that you can try. So as you are preparing for the next exam that's coming up, besides the practice exam that I'll give you, those are additional questions that you can use to practice. So that's it for my lesson on stoichiometry. In the next lesson, I'm going to talk about stoichiometry for a situation where there's limiting reactant. So in all of these problems, we assume that we had more than enough of whatever other reactant we have. But you guys know, if you ever tried to make something in the kitchen, there's always going to be one thing that you run out first, and then you got to go run to the store to get more, right? Otherwise, you can only make so many pancakes. So that's what we're going to be talking about next, is which reactant would run out first in the case where you only have so much of each one. And so I'll see you in that next lecture.